Welcome back, everybody. So, this is the video I'm going to do all NCERT questions with examples. So, this is NLM, Newton laws of motion. So, given the magnitude and direction of the net force acting on in these cases. So, first of all, concept of net force. Definite is sum of vector sum of all forces acting on it. Acting on body. And here, if F net is equal to, according to Newton's second law, the force acting on the body is equal to, it is equal to rate of change in dp by dt. If force is equal to 0, p is equal to constant. But this velocity is also constant. So now based on this concept, we will complete it. The raindrop falling with constant speed. Constant speed means v is equal to speed of force is 0. That means acceleration is also 0. Since a is equal to dv by dt. So dv by dt. Therefore a equal to 0 means that implies f is also equal to 0. Net force is 0. A carc of mass 10 kg floating on water. So equilibrium. Floating means equilibrium. So then also net force F net is equal to 0. The F net is vector sum of all the forces on floating body, that is upthrust minus mg. Mg is downward upthrust. These two are equal, so it will become 0. The kite skillfully held stationary. Stationary is given. So net force is 0. Stationary, then F net is equal to 0. Car moving with constant velocity. So here again constant velocity. So same like first option. The high speed electron in the space far from all material object. So indirectly is giving. So there is no matter, right? Only this electron is the material object. Far from material object means, so the R equal to infinity we can take. So for gravitational force between this electron and that material is 0. There is no force acting, not net force. No force is acting. No force acting on this electron because it is far from the materials. R equal to infinity according to gravitational force formula. This will. So now next question. A pebble of mass 5 kg is thrown vertically upwards. So now consider 5 kg, 0.05 kg pebble. Pebble means it is a round shaped object vertically upwards. When this universe is created 4.5 billion years ago, So the space is full of pebbles only. These pebbles, because of gravitational attraction, they form the present shape of the planets. So in the gravitation, this theory will come. In Big Bang theory also the same explained. Origin of universe. Right. So it is vertically upward motion. Is asking the net force on the pebble. So here thrown vertical upward give the direction of magnitude of net force. Here net force means only mg downwards during upward motion. During is downward motion. Downward motion also it is after reaching the maximum height it is coming down, right? It is reaches to maximum height where v is equal to 0. This pebble is coming down. So there also mg downwards. Okay. And at the highest point where it is momentarily at rest. So here also mg downwards. At highest point means v is equal to 0, but acceleration is not equal to 0. So this one statement, the situation where v is equal to 0, acceleration is not equal to 0, that is maximum height point. Highest point of vertical projection. Similarly, if v is not equal to 0, velocity is not equal to 0, but acceleration is 0, that is uniform motion. In uniform motion, the velocity is constant but acceleration 0. So now, to answer the change if the pebble was thrown at an angle 45 with the horizontal direction, ignore resistance, do your answer changes? Means here, what is asking means these values means at highest point mg downwards, while it is coming down mg downwards, it is going upwards means so we are projecting the particle with 45 degrees with some initial velocity with horizontal 45 degrees. So in horizontal direction ax is equal to 0 and ay is only g. So whatever along the path, so it is reaches to maximum range because theta is 45, the range is maximum will come. So every instant g is acting downwards. That's why path is projectile and parabola. At the maximum height u cos theta, vertical velocity is 0, even though there also mg downwards. So in all the cases mg is downwards only towards the earth because your reference frame is earth. So for this answer, do your answer changes if the pebble was thrown at an angle 45 means not? No. Simply. Right. Coming into next question. Give the magnitude and direction of net force acting on the stone of mass 0.1 kg just after it dropped from the window of a stationary train. Stationary side means free fall, right? Free fall. That equal to net force is only here. The net force is mg and it is downwards. Coming into B. Just after it is dropped from a window of a train running at constant velocity again. So constant velocity means there is no acceleration is 0 on means train also not having acceleration. So the stone also will not get any acceleration. So again free fall. So net force is equal to mg downwards. So that m value is given 0.1. If they are asking give the magnitude means how much will come 1 Newton. And here g value 10 you take for simplicity is mentioned above, so no problem. And here mg same 1 Newton is downwards. So now C option. just after it is dropped from the window of a train as a rating. So now see, train is as a rating like this. A is equal to 1 meter second power minus 2. So now I am dropping a stone here. So the stone have acceleration in opposite pseudo acceleration opposite direction minus 1 meter second power minus 2. So now wind acceleration is asking net force. Here actually the force in time being, it will be resultant in the direction. So path will be like this. But here the question see clearly just after it is dropped. So that means this acceleration no need to consider, only mg again 1 Newton downwards. Okay, this is the option. Now, so D, lying on the floor of a train which is accelerating, the stone being at rest relative to the train, neglect a resistance, net force is asking. So this is the floor of train, here stone is there. So because of acceleration of the train, so the stone also getting acceleration in this direction. Okay, na? And here given the rest relative to the train. Therefore, there is a some other force that is in the form of friction is acting in opposite direction, which is equal to ma. So net force is equal to 0 here. Stationary relative to accelerating, even though it is accelerating 1 meter second power minus 2 in the direction train. So the stone has to move opposite direction. It has to go back. But the friction, it is in the rest means relative to the train rest means there is a friction force acting in the direction. That's why the net force is equal to balancing 0. So this is answers. Next, one end of the string of length, the particle and mass m, and small peg on the smooth horizontal table. The particle moves in a circle with speed v. So the particle, so horizontal table is there. So here on peg means it is support. So one small mass is moving along this in the radius r. So now everywhere tension is equal to T. So which is equal to tension is C, which is equal to mr omega square. Because it is a horizontal circular motion, right? Smooth horizontal table, it is rotated. So everywhere is T only. So there is no right. The particle motion circular speed with V. Net force on the particle is T. So the astronaut accidentally gets separated out of his small space accelerating in interstellar space at constant rate. So acceleration of the spaceship is given. What is the acceleration of the astronaut? That instant after he is outside the spaceship. So just after outside, so only this acceleration will having. So acceleration of astronaut is equal to acceleration of spaceship just after, right? That equal to acceleration of spaceship. So that equal to 100 meter second power minus 2. So this is very easy question. A constant retarding force is given, is applied to a body of mass 10 kg moving initially with speed, initial speed. Given data check once. Retarding force. So means it is changing the velocity, means bringing stop. So F is equal to minus 50 Newton. M is equal to 20 kg. Initial velocity is equal to 15 meters second inverse. So V coming into stop means V is equal to 0. How long does the time you want to find out? So now T is equal to V minus U by A. So that is equal to 0 minus 15 by A is equal to F by M, 50 by 20. So that equal to this mass 6 seconds. So this is answer. So now a constant force acting on the body of mass 3 kg. So given data mass is given, changing the speed from initial speed to final speed in 25 seconds. Therefore, acceleration is equal to, I can find out immediately, 3.5 minus 2 by 25. That equal to 1.5. So 1.5 by 25. So that equal to 0.06 I can write. 25 6 is 150. So now 1.5 means 0.6, 0.06 only. Right. So now 150 after 2 means 1.5, correct. After 2 decimal will come, right. Now acceleration. The direction of the motion of the body remains unchanged. What is the magnitude and direction of the force? Magnitude is asking. So direction is remains unchanged means here velocity is increasing. So final velocity is increasing. So it will be in the same direction of velocity. So positive direction only along the motion. So now magnitude of force is acting. What is the magnitude and direction of the force? Magnitude is equal to MA. So M is equal to 3 into 0.06. So that equal to 0.18 newtons. And here some concept I want to tell. The force direction of the force is equal to MA bar. That means the force is parallel to acceleration. Similarly, the force is parallel to momentum. That means parallel to velocity direction, change in velocity direction. And the change in velocity direction equal to direction of motion. If it is change in velocity is positive, that is in the direction of motion. If it is negative, opposite to direction of motion. If it the perpendicular, A and DV are perpendicular, then it will be circular path, curvilinear path. So this you remember, very important. Now seventh one. A body of mass 5 kg is acted upon by two perpendicular forces. So two perpendicular forces, 8 newtons and 6 newtons. So here is the problem is not mentioned. There is a body of mass M, 5 kg mass. Is not mentioned 8 newton is acting in which direction, 6 newtons acting in which direction. So whatever you can take. So I will go with 6 newton here. And this is 8 newton. And here magnitude and direction of the acceleration of the body is asking. So these two are perpendicular and force is a vector. Therefore, the resultant force will act in the resultant force due to this is act like this. This is the resultant force. So 10 newtons according to Pythagoras theorem. And to find out the direction of the force, here I will take alpha. Therefore, tan alpha is equal to 8 by 6 y by x, that equal to 4 by 3. then alpha is equal to tan inverse 4 by 3. This tan inverse 4 by 3 with 6 newtons. So now automatically with 8 newtons it will be tan inverse 3 by 4. Theta is equal to 90 minus alpha, that equal tan inverse cot inverse 4 by 3 or tan inverse 3 by 4. Both are same one. With 8 newtons. With 8 newton of force. This is the angle made by the resultant force vector or magnitude of force vector. So now acceleration of the body, magnitude and direction of acceleration. This is the force 10 newtons. And acceleration is equal to force by mass, that equal to 10 by 5. 2 meter second power minus 2. So in resultant force direction only acceleration also present. Because force, net force and accelerations are parallel. Already we discussed. Hope you understand this, right? Coming to next. The driver of three-wheeler moving the speed of 36 km per hour. So convert into 36 kilometers into meter second also. Depends, right? So u is equal to 36 km per hour, that equal to 10 meter second. The child standing on the middle of the road brings his vehicle to rest in 4 seconds. Therefore, time taken to stop 4 seconds means v is equal to 0. So immediately A I can find out. A is equal to minus will come, v is equal to 0 stopping. Therefore, minus 10 by 4, that equal to 2.5 meter second power minus 2. 10 by 4 means 2.5 correct. Just in time to save the child. What is the average retarding force of the on the vehicle? So retarding force F is equal to means braking force. F is equal to M into A. So here M is equal to total mass 465. 465 into 2.5. So this is minus. So now 25 5 125, 25 6 150, 162, 100 and 16. So 116.5 newtons of force. This is the answer. So total mass I have to take here 465 is the mass. 1162.5 or 1.1625 kilonewtons also I can write. So here a racket is lift of mass. Racket with a lift of mass. So it is lift off. Its mass is equal to mass of the racket is equal to 2000 kg. 20,000 kg, sorry. So that equal to 2 into 10 power 5 kg. So he is blasted upward with an initial acceleration is given. That means, so consider a racket PSLV3. So here satellite. The gas are exciting, gives the upthrust. The excited gas gives the upthrust to the this racket mass, and it has mg downwards. So now actually in the racket case, F net ma is equal to upthrust minus mg. So here A equal to dv by dt, where mass is changing from initial mass m0 to m at any instant, any time, because fuel is consuming now. So A equal dv by dt. According to that, you can find out. So here that and all known here. Ma A is equal to 5 is given. Therefore, ma is the net force here. So according to free body diagram, net force is equal to the vector sum of resultant and first law of Newton. Ma is equal to vector sum of all the forces here upthrust and mg. So upthrust I have taken positive and mg downwards because upthrust is in the direction of resultant force. That equal to is asking upthrust only. Therefore upthrust is equal to ma plus mg, that equal 2 into 10 power 5 into a equal to 5 plus 2 into 10 power 5 into 10. G is equal to 10. That equal to 2 into 10 power 5 take common means 2 into 10 power 5. 2 into 15, 30. 30 into 10 power 5. So that equal to 3 into 10 power 6 newtons of force. Upthrust is this much is acting. Means gas is exerting of upthrust on the racket is this much. This is answer. So whereas coming into this problem, the body of mass moving initially with a constant speed of 10 meters second was constant speed means acceleration is not there. D to north. So the body is moving. So D to north. So the body of mass something 0.4 kg small is moving towards north with constant speed. Therefore A is equal to 0. So here gravity no need to consider. Is subjected to constant force of 8 newtons directed toward the south. Therefore we are applying the force 8 newtons towards south. And this force is constant force towards south for 30 seconds. Constant force is constant means here acceleration also constant. Acceleration is equal to F by m. So F by m. That equal to F is equal to here 8 by 0.4. So that equal to 20 meters second power minus 2. So this is acceleration up to 30 seconds. So t is equal to 30 seconds. The acceleration is constant, that equal to 20 meters second power minus 2. That means 0 to 30 seconds acceleration is 20 meters second power minus 2 only. Now take the instant the force is applied to be t is equal to 0. Means where at what time the force is applied, t is equal to 0. Therefore 0 equal 30 seconds. The position of the body at the time of to be at t is equal to 0, the position x is also 0. For example, here consider. And predicted position at t equal to minus 5 seconds means initially where it is. So initially, therefore, it is going up with constant speed, you said, na? So when it is coming down, that time this force is applying, right? Otherwise, when this force is applying on the body downwards, that time is equal to 0 you have to take. That means t is equal to minus 5 means it is in upward motion. So therefore, I hope understand this. Position means displacement in upward direction, that equal to x is equal to u into t. So that equal to 10 into 5. That equal to 50 meters. So somewhere it is minus 50 meters upwards. Okay, this is minus. Otherwise, here you can take minus 50 meters onwards, it is coming down. So here this is a minus 50 coming like this. Right. So now at t equal 25. So if you see minus 5 to here 0, this is minus 5 second, minus 5 seconds to 0. So this time minus 5 to 0, it is moving constant speed only. When time reaches to 0, we are applying the force 8 newtons. Means 0 to 25, 0 to 25, it is moving with the constant force, constant acceleration. And at t is equal to 0, minus 5 to t equal to 0, it has some velocity, right? That is 10. Up to t is minus 5 to t equal to 0, there will be 10 meters second inverse velocity is there. It is moving constantly upwards. towards north up to t equal to 0 seconds. There I applied 8 newtons downwards. Constant force is acting downwards up to 30 seconds. Therefore, the position at 25 degrees centigrade I want to x is equal to ut plus half at square. That means, so here see, why here x equal to ut have taken means constant speed, so acceleration 0. But here x is equal to, at t is equal to 0 seconds of time, it has an initial velocity 10 meter second inverse. Up to 20, after 25 from t equal to 0 seconds, 10 meter second inverse in upward direction. Okay, now it is in upward direction. T equal to here, t equal to 0 seconds. The velocity is upward direction. From -5 to 0, it is traveling upward direction in constant velocity. So now at t equal to 0, I am applying the force 8 newtons downwards. So now initial velocity is minus I will take here. So acceleration is downwards positive I will take. So now position x is equal to minus 10 into 25 seconds. After 25 seconds, position I want to find out. Plus 1 by 2 into a is equal to here 20 meter second power. Up to 30 seconds, 20 meter second power minus 2 only. So 20 into t square, 25, 625. So that equal to 625 into 10 and minus 250. Therefore 6000 meters. That equal to 6 kilometers. The particle travel to 6 kilometers down again. Okay. So minus 5 to, at initially minus 5 to 0. Otherwise 0. From 0 to 625. At 0 it is starting downwards. Right? The direction changed it to downwards. Because 8 newtons is applying downwards now. So it has to come down. So now 100 seconds. So after reaching 30 seconds, t equal to 0 to 30 seconds. So what happened? Force is not acting, right? The force is not acting means it will move again constant velocity. So here what is the constant velocity? Means after 30 seconds, t is equal to 30 seconds after, what is the velocity is equal to how much? So with this velocity it will move remaining seconds. So that implies v equal to u plus, means initially t equal to 10 seconds, u is equal to t equal to 0 seconds, it has 10 minus 10 plus a equal to here 20 meter second power minus 2 into u plus at. So at t equal to 30 seconds. So this is 5 600 means 590 meter second was. So now it will travel next how many seconds here? After 30 seconds, 70 seconds, right? So remaining 70 seconds, it will move constant speed, that equal to x is equal to 590 into 70. So 700, 7 nines, 63, 4100 meters. So this is 41.3 kilometers. This is 6 kilometers total. 47.3 kilometers from starting 0 seconds. Or minus 5 meters means, so minus 50 is subtract, you will get answer, right? Minus 50. 6 means 47,300 minus 50. Therefore 47,325 meters. So final position, right? At 100 centimeter. So this is this problem. I hope you understand. Once again, I am trying to explain this. See, what is asking means a body of mass is given. Okay. So initially with constant speed, 10 meters second is moving upward direction. Initially, it is moving upward direction. So after some time, I don't know what after what time. So somewhere in its motion, so we are applying the force opposite direction. Initially it is moving upward direction with constant speed. At instant t is equal to 0, I start applying 8 newtons of force downward direction. Therefore motion is reversed now. Means this constant force towards south acting for 30 seconds. That means up to 0 to 30 seconds, it moving with the constant acceleration. Force is constant means acceleration is constant. That acceleration you find. So now initially is asking that find the position of the body at t is equal to minus 5 seconds. Means it is moving minus 5 seconds means downwards. T is equal to 0 here, right? Here. So t minus 5 seconds here somewhere it will be position. This is minus 50. So here it is. And before 8 newtons apply, it is traveling, right? 5 seconds is traveled. Minus 5 seconds means what? 5 seconds of time it traveled. So x is equal to, with constant speed, therefore x is equal to ut. So you will get 50 meters. It is a minus value. Okay. Minus means it is initially at one point like this. If you take graph, it is equal, t is equal to 0 seconds. And this is take as x is equal to x-axis distance and the time. If you take the time x-axis here, so it is minus 50 meters initially. It is minus 50 meters at t equal to minus 5 seconds here. So this is the point. Now t is equal to 0. It is a reference line I am taking, x equal to 0. So this is t equal to 0, x equal to 0 reference line. So initially it is here. Okay. So this point, it comes to here constant speed xt graph. This is t and x graph, constant speed. So here after again 25 seconds it traveled some 6 kilometers of distance. So 6 after 25 it is travel, and here it is ut plus half at square graph. So this is 6 kilometers. So then after again it travels 41 kilometers. Time increases 100 seconds. So it will be here somewhere. So like this you can take the graph values. Right. So finally from t equal to 0, 41 300 minus 50 you have to take the total. So now coming into 11th one. Next question. A truck start from rest. So initial velocity is given. And accelerates uniformly, uniform acceleration. So at t equal 10 seconds, a stone means there is a truck here. This is in friction. We will discuss about this horizontal motion. So it is a truck is moving with a constant acceleration 2 meters second power minus 2. So there is a 6 meters person here. He dropped a stone. Right. At t equal 10 seconds. The stone is dropped by the person standing on the top of the truck 6 meters high. What are the velocity and acceleration of the stone at t equal to 11 seconds? Means t is equal to 1 second. In t means first of all, at t equal 10 seconds, a stone is dropped. So t equal to 10 seconds, what is the velocity of this truck? We have to find out. T equal 10 seconds. Velocity of the truck is equal to constant acceleration is given. Therefore, initially 0 plus 2 into 10, that equal to 20 meters second verse. So truck is moving at t equal 10 seconds. Truck velocity is equal to 20 meters second verse. Therefore, the stone also will get 20 meters second verse in opposite direction horizontally, and vertically 0. In that no doubt at all. Vertical direction 0 speed, but in horizontal direction 20 meters second verse. So the stone will not fall freely. At instant it have direction downward. But time being, it moves horizontal direction like this. It will come and fall like this. So he's asking that at t is equal to 11 second, means after t is equal to 1 second, what is the velocity and acceleration? V is equal to, acceleration is g, in that no doubt. Acceleration is always g. Any instant, acceleration is vertically downwards g. So this is no doubt g. But velocity is different. After 1 second, the velocity will be having two components. So Vx is V equal to Vx I cap plus Vy j cap. Here kind of projectile motion, horizontal projection motion we have to use. So Vx is equal to always same, that equal to 20 meter second inverse, and Vy is equal to Uy is equal to 0 minus g into t. So that equal to t equal to 1 second, 10 meter second inverse. In downward direction 10 meters. The minus indicates downward direction. So therefore V is equal to, I can go with root over means 20 square means 4 or 500 means root over 500, that equal 10 root 5. 10 root 5 meter second. So this is, I hope you understand this question. So there is a lot of concept is there. So truck is moving with constant acceleration at 10 equal, here see one more point, at 10 equal to, at time is given, means instant of time you have to take. At 10 second, what is the speed of truck? So that is the speed on the stone in or on the person in opposite direction to the truck motion. Pseudo acceleration, pseudo velocity. So this is horizontal velocity given to the stone now at that instant. So after 1 second, in 1 second of journey, it is moving in parabolic path, like horizontal projection. So after at any instant of time, the velocity of the particle is equal to Vx I cap plus Vy j cap. So that will substitute means we will get this concept have to apply compulsory, in that no doubt at all. So simply it will not come, right? And yet t equal to 11 seconds. So not total time t equal to 11 seconds. So 1 second only have to take there. So right. Now see, a bob of mass m hung from the ceiling of roof, string 2 meters long, is set into oscillation, right? See, this is the ceiling. So there is a bob of mass with length 2 meters. There is a one bob of mass 2 meters length, and it is 0.1 kg. Is set into oscillation, means like this: extreme position, and mean position. So here it has velocity either in the direction or in the direction. These are velocities and maximum at the mean position. So here velocities are 0. It has maximum potential energy and 0 kinetic energy. At the point of mean position, potential energy is minimum, not 0 always, and the kinetic energy is maximum. So here kinetic energy is 0, potential energy is maximum. Maximum potential energy here. Right now, the question is, what is the trajectory of the bob, the string? And trajectory means it is like this, curved path. The bob is cut when the bob is at, okay, is given positions. The question is given positions. One of its extreme position. So any one direction here. So at extreme position, velocity is 0. So now you cut this string, then it will fall down, vertically downwards. And for example, here if you cut the string, it will move tangentially. This is the question they're asking. At mean position, we are cutting the string means it will fly off along the tangential direction due to inertia of direction. So that you know. And here because of vertical means velocity 0, it will feel it falls. Right? Inertia of rest. Maybe tomorrow they can ask why it is falling down. Which type of inertia is involved there? It want to be in rest only. It is not moving. It want to be rest. But support is cut. It will fall freely fall. Right? and now it is here, it want to move in this direction. So cut means it will move in the direction, no external force. Unless acting external force, it continues its motion or it continues its state of motion. Right. So this is, I hope you understand. Along with the concept we will go, then better. Now a man of mass 70 kg, given 70 kg mass is given, and stand on a weighing scale in a lift which is moving. See, he is standing on a lift, right? So we'll go more space. So there is a lift here, consider. So this is lift. So there is a man is standing, 70 kg standing. The weight of the lift is given. Anywhere mass of the lift is not given. Okay, only mass of 70 kg man is there here on the floor of lift. So now it is moving upwards with uniform speed. Uniform speed only, right? Upward with uniform speed. Uniform speed means acceleration 0. So A is equal to 0. Either upward or downward. Uniform speed means acceleration 0. So now he's asking weighing, on the weighing scale. He is standing on weighing scale. So now the reading of scale is equal to his weight only, right? The reading is equal to his weight. That equal to 70 kgs. 70 into 10. That equal to 700 newtons. So this is his weight. Now downward with uniform acceleration. So it is going now. Lift is moving with downward acceleration. So lift acceleration downwards. A is equal to 5 meters second power minus. So now there is a normal force here, reaction force on the person here. Person is standing. So it is mg is downwards, and pseudo acceleration on this person is upwards. That is the reaction or pseudo force that equal to. Therefore, so normal reaction is equal to mg minus ma. So m into a is how much here? Is moving downward with acceleration. So there is a pseudo acceleration, pseudo force upwards, mg minus ma, that equal to m into 70 into 5. So 350 newtons. Half of his initial weight. The reading shows 350 newtons. Now in the C, so now it is opposite. So now the reaction force will become mg plus a. So that equal to 70 into 15. 15 7 ja 105. Therefore 1050 newtons. So this is the reading. What would be the reading if lift mechanism failed and it is hurtled down freely under the gravity? It is okay. Lift is going. So what would be the reading if the lift mechanism is failed? But weighing machine is shows the is weight normal. Therefore, the normal weight R equal to mg. It is going under the freely falling, right? Okay, freely fall, right? Freely fall under gravity means A equal to G, and it is going under A equal to G is given. It is moving down. Therefore, mg minus mg. This is the D option. Freely fall, that equal to 0. Okay, that equal to 0. Not mg. It is moving under down freely under gravity. Means acceleration is g. Acceleration of the lift is g. Now 14th question. So here figure is given. I have not taken this figure. So I hope the figure is like this. So given what is the force on the particle t equal 0 second, t equal impulse. So which graph is given? I have to check. So I will come with the figure. I took the graph here. So xt graph is given, and already the graph experiments I have given. Graphs I explained, I think so. The slope of xt graph. The slope of xt graph gives velocity. So now here, from some time initially before observation, so t equal to 0, you are observing the motion of the particle. At that time is already it is at 0 meters. It has some initial velocity. At t equal to 0, it has some initial velocity. Okay. So x equal to 0. Means it is somewhere back of you. Okay, now you are observing this time. That's enough. The motion started before your observation. Okay. So now after 4 seconds, so velocity, this is the slope, right? So that equal to slope is equal to, in the 4 seconds, the velocity is equal to increase it to 3 by 4. Slope 3 by 4 meters second version. So after 4 seconds, the slope is 0. That means velocity is equal to 0. It is rest. Means after 4 seconds, it come to rest. Means 0 to 4 seconds, the velocity is increased. Constantly increased. So velocity is constant here. So velocity constant. So here acceleration is equal to 0. And x equal to 3 meters here. And the time equal 4 seconds. Therefore, slope of this one equal to 3 by 4 meter second. Now is asking, what is the force on the particle for t less than 0? So here some force is there, right? Force on the particle is equal to ma. So here I want to find out a in this case. So it is coming with 0 displacement. Displacement is equal to 0. So here there is no displacement for time taken. 0 displacement is equal to initial velocity. The figure showing the figure graph mass is what is the t equal to 0 means velocity is not given here. One dimensional motion velocity is not given. Therefore, half at square ut plus half at square I will take. So then ut is equal to minus half at square. So from here t is equal to some less than 0 seconds. The force is equal to, this is the answer. The force F equal to m into 4 into A is equal to 2u by t. So that equal to 8u by t is the force equation. T less than 0. So force for t greater than 4 seconds. So force here, t greater than 4 seconds, here to here. There is no force, right? Slope is 0. So I think here also slope 0 only, na? This is no need consideration. This consideration is no need. Here slope is 0. That means velocity 0. Velocity 0 means acceleration. So velocity 0 means acceleration is also 0. Change in velocity is rest only, this represents this line from here less than t equal to less than 0. It represents the rest position, right? So there is no change in the displacement, 0 only. And here to here also rest position only. So therefore rest means no force. Force is equal to 0. This is under no need. No. So this is wrong. So here force is equal to, here force is equal to 0. Here also force is equal to 0 for t greater than 4 seconds. And 0 to 4 seconds. Velocity is constant here, right? This x by t slope is constant. Therefore, there also force is 0. In all three cases, force is equal to 0 because this is acceleration 0 and v equal to 0 or rest in both the cases. Now, option B. The impulse at t equal to 0 seconds. Impulse means change in velocity. So, at t equal to 4 seconds, velocity is equal to 3 by 4 meter second. So, these two interval I will take. So, impulse means here velocity at t equal to 0, velocity is equal to 0 I will take. The impulse I is equal to change in momentum m into v minus u. So, that equal to m into v. V means final velocity at t equal to 0. That equal to 3 by 4. So, m is 4 kg, therefore 4 get cancelled. 3 kg meter second. And impulse and t equal to 4 seconds. Same, t equal to 4 seconds means either year to year you can take or year to year you can take. Because anyhow this is only will come, that equal to I equal to again mv. So that equal to 3 kg meter second was only. That no doubt at all. At the both the impulse, change in impulse, here the velocity is equal to 0, but here velocity is equal to 3 by 4. Therefore the change in impulse means compared to these 0 to 4 seconds only you have to compare. Velocity is existing between 0 to 4 only. That's all. So I hope this is understand. First we confused with force. So slope, velocity, acceleration. So 0 right now. Coming into this one. So two bodies of mass 10 kg and 20 kg respectively kept on a smooth horizontal surface are tied at the end of. Okay, this is trying to explain free body diagram. So now free body diagram concept came. Hereafter up to now only force, acceleration, velocity concept only. So here 120 kg is there and here 10 kg is there. These two are connected by string, light string, massless string. If mass is there means total mass you have to consider here. So massless string. So here is the tension and here is also tension same. And now the horizontal force 600 Newton is applied. First of all, this is A consider, this is B consider. On A means A, that means this is A. So 600 is force is applied. So what is the tension in the string in each case is asking. Next after second case is applying 200. So now in this case first system consider, this total is one system means then acceleration is equal to F is equal to 600 by total mass equal to 30. So that equal to 20 meter second power minus 2. Now take a single body, free body diagram of 10 kg I will take because a force acting on 10 kg. So there is a tension here and 600 Newton is applying. 600 Newton is applied, horizontal force 600 Newton is applied along the direction of the string. Okay, this 600 along the 600 like this only. And it is moving like this acceleration. So therefore 10 into A net force is equal to T plus 600. T plus 600. So here B along the direction of string. 600 Newton is applied to A and B along the direction of the string. For the tension in the string each case. So T is equal to 10A is the net force. So T minus 600 here, that equal T is equal to 800 Newtons. So we'll verify with the 20 now. So if you similarly this acceleration 20 if you take means, so tension is always pulling force, it is away from the Newton. So he's asking along the string means 600 also is acting in this direction. If you take in this direction 600, T is coming negative. So that is wrong. Therefore, T cannot be negative. So now That's why the acceleration is in the direction 20 kg also. Therefore, 20 into acceleration 20, 20A is equal to free body diagram. So for 20 kg, free body diagram. So acceleration and there is a 600 newtons and tension. So maybe in the direction 600 you take along the string 600 in the direction. Therefore 600 minus T. Then T is equal to 600 minus 400. So that equal to 200 newtons. So here 800 Newton is came. So this is wrong. We have to check now. So now A equal to 20. So now along the string means like this. If you take means T is equal to T is always pulling force. So then 600 in the opposite direction. Therefore MA that equal 10 into A is equal to T minus 600. So this is 800 Newton. So once something I will come once again. This diagram is not clear. Right here it is pulling force you will take. This is the 600 Newton is pulling. But direction is not given. Therefore it is pulling means. So this I will take 10 kg body pulling in this direction. And 20 kg here is there. 20 kg there will be tension here. So T is equal to 20A. T is equal to 20 into A. That is equal to 400 newtons. So the string. So now here also see now 200 T minus 600 that equal T is equal to 800. So we'll go with 400. So this is right. So now if you take here 20 kg pulling force tension, this is the tension, this is the 600 newtons pulled. So now 20 into A is equal to 600 minus T. Then T is equal to 200 newtons. So it is correct or not, we will check. So here T is equal to 400 is coming and T is equal to 800 is coming. So this is wrong assumption. So now T equal to here 200. Tension means string should have same tension. So 200. Now 10 kg body take. In this case 10 kg body is take. So now on the 10 kg body T is equal to 10A. Right. So here A is equal to 20, 200 newtons. So this is correct. So T is equal to how much is come? 200. Not 400, 800. I hope this is, once again I am telling. So here space, I forgot to take space clearly. So once again I will rub and I will write clearly. So this force is pulling force you consider. So it is pulled. 20 kg is pulled along the string direction means like this. 20 kg is pulled by 600 newtons in second case. And in the first case 600 is pulled. Means 10 kg is pulled by 600 newtons. So now tension like this. So initially the acceleration is equal to total net force by total mass, that equal to 600 by total mass is 30, 20 meter second power minus. So this is the acceleration of the system. So now you take 10 kg as a free body diagram. So it is having acceleration like this. Tension is always pulling and there is a pushed 600 newtons is pulling in the direction. And in this case 20 kg, there is no force acting on 20 kg, only the force is T, that equal to 20A. Here T is equal to 20 into A, that equal to 400 newtons. So this T also 400 has to come. We will check now. 10 into 20 is equal to T minus 600. So therefore T equal to 800 is coming. So this is T is not 800, T is not 400. So this assumption is wrong. So now means tension is not satisfying here. Therefore 20 kg pulling 600. So 20 kg. Here 10 kg free body is equal to T. On 10 kg only T is the tension force. So that equal T equal 10A. And 20A is equal 600 minus T, then 200 satisfied. Therefore, T is equal to 200 newtons is capable. Otherwise, those two are not pulled by 600. So next problem. So here this is Atwood mission. By reading you can tell. So in Atwood mission, A and tension direct formulas after explanation. So see, it is single fixed pulley suspended by M1 and M2 mass. According to the definition of acceleration is equal to total means net force. So apart any acceleration, this is downwards means it will be upwards then automatically. Then M1 minus M2 into G. This is the net force by total mass M1 plus M2. Frictionless pulley, massless strings. This is the condition in proving the Atwood mission. So free body diagrams also you can write. Tension is same. Tension is always pulling the blocks. So now tension is equal to 2m1 m2 by 2m1 m2g by m1 plus m2. So this is tension formula and acceleration. So substituting will get answer. So now 17. So here see this is related to conservation of momentum. So he is telling that a nucleus is at rest in the laboratory frame of reference so that it disintegrates into two smaller nuclei. So there is a nucleus at rest. So U is equal to 0. Therefore initial momentum is equal to 0. So now it is disintegrated into two parts. So one is having V2 velocity and another one is having V1 velocity. So that the product must move in opposite direction. That is the question. How it will be C1C. Therefore these two masses. So the ratio is not given. Therefore I will take M1 and M2. Therefore initial M is equal M into 0. Initial momentum is equal to final momentum. M1 into V1 plus M2 into V2 bar and V1 bar. So therefore M1 into V1 bar is equal to minus M2 into V2 bar. That means M1 and M2 cannot be negative state. Therefore V1 in the direction of opposite to V2 or V2 is opposite to V1. Therefore those two will move opposite direction according to conservation of momentum third law. So now here also same third. This is also related to conservation of momentum only, I think. So read once. Two billiard balls each of mass. So mass are equal. Moving in opposite direction. So two billiard balls of they are moving in equal mass in opposite direction with the speed 6 meters second verse. That means same speed. And rebounds with the same speed means here the collision will happen between them. And here without collision concept you have to tell. So after collision it is rebouncing with rebounds means same velocity 6 meters second verse. This is 1, 1, 2 and it rebounds with 6 meters second inverse and they are on the same line. So for one dimensional collision only have to consider here. The impulse important to each ball. For impulse is equal to change in momentum and here perpendicular in the same line that equal to 2mu will come, right? So for impulse we have a three formulas that I will explain in the next problem. So 2 mu, that equal to 2 into m is equal to 0.05 into 6. So that equal 0.6 kg Newton second or kg meter second power minus 1. So this is the impulse supported by both and opposite direction. So the first body will move in positive x direction, second body will move opposite to initial direction, right? So this is impulse calculation, conservation of momentum. So now 19th one. So a cell of mass 0.2 kg, mass is given, fired by a gun of mass. So it is also recoiling velocity, means application of conservation of momentum and third law. The recoiling speed of the gun is asking. So initially gun is 100 kg, it is at rest. 100 into momentum 0. Initial momentum is equal to final momentum according to third law. What is third law telling means net force is equal to 0. Action and reaction. The sum of action and reaction is equal to 0. Action is equal to minus reaction. Therefore, net force is equal to 0. The net force 0 means momentum is constant. So for initial momentum is 0. So now the muzzle speed is 80 meters second verse. So then recoil velocity of the gun is asking. If the muzzle speed of the cell is moving with this speed, therefore 0.02 into 80 less 100 into V. Therefore, recoiling velocity V is equal to minus m into u by capital M according to formula. So that equal to here 80 into 2, 16, 1600, 80 into 2, 160. So after 2 means 1.6 by 100. So that equal to 0.0016 meter second volts. If you observe clearly, the less mass is moving with more velocity, 80 meter second volts. The more mass is moving with less velocity. This is conservation of momentum. Okay. And in charge also, charge invariant. This conservation of momentum only will tell there. Right. So that topic in electrostatic I have explained that why charge is invariant. So with momentum only I have to explain. Right. So now a batsman deflects a ball by an angle 45 without changing its initial speed, means rebounds, is equal to the 54 kilometer hour. So speed equal to 54. That means u is equal to convert into meter second words. That equal to 15 meter second words. And m is equal to given 0.15. So now here angle of 45 without changing its initial speed. That means the total angle, the ball is coming like this and deflected by, the ball deflected by like this. So this total angle is given 45. Therefore in these cases the change in momentum, the impulse means change in momentum I, that is equal to, so here 2 mu cos theta, this is a bat here. So it like this. Here theta is with normal, that equal to 2 mu cos theta. So that equal to 2 into m equal to 0.15 into u value 15 meter second verse into cos 22.5. So exactly I don't know. This is here I will stop. Cos 22.5 degrees. He has to give actually cos 22.5 value here. Forgot. In mains exams and all they will mention this cos 22.5 value. Right. So now a stone of mass 0.25 kg is tied to. So these and all come from somewhere to this question because these are not here actually. These questions are not here. Means these diagrams because I am entering and coming now. So the diagrams come forward. 0.25 kg tied to a end of the string while around the circle of radius 0.5 with a speed of 40 revolution minute. So now omega is given. Omega is equal to 40 into 2 pi. One revolution have 2 pi radians by 60 seconds. So this is equal to 4 pi by 3. Oh, 4, oh yeah, 2 1 2 3, 4 pi by 3 radian seconds. Omega revolving. Radius is given 1.5 meter. M is equal to 0.25 kg. Now, what is the tension in the string? What is the maximum speed with which the stone can be whirled around if the string can withstand maximum tension? Okay, first tension find out. So tension T is equal to mr omega square. Already in the first question came this is. So mr omega square substitute 0.25 into r value 1.5 into omega square 16 by 9 into pi square. You can go pi square as 10. So this is answer, tension will come. Now if T is equal to 200, then what is the maximum speed? Speed is equal to question mark. So directly they are asking speed, therefore I can go with T is equal to mv square by r. So v square is equal to root over T into r by m. So that equal root over T equal to 200 into 1.5 by m. M is equal to 0.25. That equal to 25 into 100. So 25 1 ja, 25 4 ja. And here 15, 300, 1200 something. So this is 15 to the 3000, 300 into 4, 12,000. So root over 12,000. So this is 3000 in means in square roots I want to write means 4 into 300 I can write. Therefore 2 into root over 300. Root over 300. So 20 root 3 I can go simply. Okay, 20 root 3. So this is elastic. So 335 approximately 1.732 into 20. So 35 meters second inverse will come. That is the answer. So in exercise 4.21, the speed of the stone is increased beyond the maximum possible value. 4.21 in exercise 4.21, where it is. Okay, we will see the diagram. The stone after the strike breaks, the stone moves radially out towards the stone files of tangent. Okay, question is asking, okay, if in exercise 4.21, the speed of the stone is increased beyond the maximum possible value and the string breaks suddenly, which of the following is correctly? Whenever it is moving in circular motion, right? In circular motion, whenever the string is cut means it will move tangentially. The answer is it moves in tangential. So the stone moves radially outwards and flies off tangentially. So B is correct. So in that no doubt. So B is correct. Now 23. So explain why horse cannot pull the cart and run in empty space. In empty space means there is no gravity and action is not possible. So it is not. Passengers are thrown forward from their seat when speeding bus stops. Speeding bus stops means there is a retardation will come. Means we are touching with the ground. So our legs will come into rest, but our top body will fall into continuous direction. That is inertia of direction. It will fall forward. Suddenly, okay. It is easier to pull lawn lower than push. See, pulling and pushing in the friction, we'll discuss this one. Okay, anyhow, here In CBSE, friction and everything is given. This is called pulling force, direction of pulling, and here it is pushing. So when you are pushing F sin theta component, this is normal force here and mg. So here normal will become mg plus F sin theta. So in the pulling case, normal force is more, therefore friction will become mu into n more. The friction will be increased. So pushing is difficult. Whereas coming into here, this is the normal force and F also. Therefore n is equal to mg minus F. mg minus F sin theta. So it is theta with horizontal. Here also theta with horizontal. So sin theta downwards side. So now mg minus F sin theta. So normal force is decreased. The normal force is decreased, therefore friction also decreased. So it is easier. That is the reason we have to push the pull the luggage and all. Not only long road luggage, also pulling is easier than pushing. So now these are the examples now. Motion of the particle of mass m directed by y equal to ut plus half at square. The force acting on the particle. So motion this is, and here force is equal to ma. So a is equal to dv by dt. That equal to d square x by dt square. 2 times you have to derivate. So if you 2 times you derivate, it will become a. Therefore f equal to ma formula. The 2 times. From that equation, we brought a equal to dv by dt or v into ds, v into dv by ds formula only. We brought this y equal to u plus half at square, right? In the derivation. In NLM means in kinematics, we have proved that calculus method, right? From that a is equal to formula only. We brought this equation, right? F equal to ma. No. So this is same, a bullet of mass 0.4 kg moving with a speed is given. Exerts a heavy wooden block and is stopped after distance traveling. So retardation force is there here. What is the average resistance force? Therefore, A is equal to here, resistance force is equal to MA. That equal to M into V square minus U square by 2S. That's enough. Change in kinetic energy by time by this one. Therefore, ma equal to a equal to v square minus u square by 2s. After finding ma, we have to substitute. Okay, a equal to v square minus u square. Then force is equal to ma. So this is force. Ma, then a equal to v square minus u square by 2s. So wooden block and it is stopped after distance is given and v is equal to 0, u is equal to 90 meters seconds. Is substitute means you will get answer. So batsman is the black same question it is. Batsman is the back a ball straight in the direction of the bowler without changing its initial speed 12 meters seconds. The mass of the ball is given. Determine the impulse that equal in the same direction means 2 mu. That's enough. So the change in impulse is equal 2 into mu. That equal 2 into 0.15 kg into 12. So here the 30 will come. So 0.3 into 12 that equal to 0 means 3.6 kg meter seconds or Newton seconds. So now, so again this is identical billiard balls are given 4.6 direction of the force on the ball. Okay, here before that question diagram this is. So now like this. So here the billiard ball is coming and hitting and rebounding perpendicular to the ball. The change in momentum is equal to 2 mu. So here it is initial momentum is equal to mu. Final momentum also mu only. So now change in momentum is not equal to 0. It is not a simple algebra. Therefore vector algebra m into u minus of minus u. Therefore plus u. That equal to mu will come. Okay. change in momentum equal to mu. Now as shown in the figure 4.6 means here it is comes. There I rubbed now, that's why. So now, well, the ratio of the magnitudes of the impulse imparted to the ball by the wall. But here before that one more question is the ratio. Okay. The speed as shown in the figure. What is the direction of the force on the wall due to each ball? So now one more diagram is like this, I think so. So force is equal to mu by t, right? So this is with normal angle with normal. So this is theta equal to 30 degrees is given. So this is 30. Theta with normal is given means the change in momentum is equal to 2 mu cos theta. Change in momentum, and it is opposite to initial direction. So opposite to the wall, that equal to minus I cap. Change in momentum. Here also this is change in momentum. Force is equal to dp by dt. That do you know? The ratio of magnitude of impulses imparted by the balls by the ball to the balls by the wall. So this is change in momentum, and 2 mu get cancelled, cos theta will come. Theta equal 30, that equal root 3 by 2. That's enough. So here theta is equal to 0, not 90. Perpendicular means don't follow the cos 90 0 like that. Not here. Perpendicular means theta equal to 0 here. Means here in the 2 mu cos theta, theta will be with normal. And if it is here with wall is given means the delta p bar is equal to 2 mu sin theta opposite minus I cap. So this is with 2 mu sin theta with wall. The ball is hitting with the wall. So this you have to remember. Rebouncing. So now next. 4.8 mass of 6 kg suspended by the rope of length 2 meters and from the ceiling. Okay, this is understand. So equilibrium means Leibniz theorem. Here 6 kg is suspended and there is a 15 newtons is acting. So here 6 kg means 60 newtons is acting, and here this is T1 and this is T2. So here I don't know theta. This is theta concept. So now G is equal to 10. Neglect the mass of the rope. No need to find out. 6 kg is suspended. Is asking the midpoint of the rope. 50 newtons of force is acted horizontally. Now what the angle of rope makes with vertical in equilibrium. With vertical this angle in equilibrium. Equilibrium means so net force is equal to 0. Therefore T1 into cos theta is equal to 6c. Equilibrium means sigma fx equal to 0 and sigma fy is equal to 0. In direction x direction, y direction is force is equal to 0. Total force is equal to 0. Therefore here similarly T1 into sin theta is equal to 15 newtons. Therefore tan theta is equal to 5 by 6. So I hope this is 0.27 theta value. Theta value is equal to 0.27 degrees. 5 by 6 or tan inverse 5 by 6 is enough. So this is answer for this one. Determine the maximum acceleration of a train in which a box lying on its floor will remain stationary. Find the maximum acceleration of train. Okay, in which box on its floor will remain stationary given that coefficient of friction means the train have acceleration consider, but box is stationary. That means pseudo acceleration is there like this. This is the acceleration of train on the box, and it is stationary means there is a friction. Therefore, mu into mg is equal to ma. So this is acceleration of train. So therefore, a is equal to mu g. Mu is equal to given 0.15 coefficient 0.15 into 10. So that equal to 1.5 meter second power minus 2. Right. This is answer. If this coefficient of friction 1.5 meter second power minus 2 moves means it will be in a rest. If it is more means it will be move backward direction. Right. It is less than this acceleration means it will not move forward. Remember that it will be stay rest only. Friction cannot give the acceleration. Right. Now, what is the acceleration of the block and trolley system shown in the figure 4.12a? Okay. Here is there see 4 point trolley system. This is I think so. This diagram W 20 kg and 3 kg 3 kg means 30 newtons. So okay, yeah. The coefficient of kinetic friction between the trolley and the surface is 0.04. So like this. Here one trolley is there. So it is dragging with the help of some 3 kg. So 30 newtons of force is act downwards. This is the tension. This is also tension. And this is some trolley. Here the force of friction Fk is there. And mu k is equal 0.4 is given. What is the tension in the string? T is asking. So now first of all find out the acceleration. Masses is given 10 kg and 30. This is 20 kg. So therefore acceleration is equal to net force, that equal to 30 newtons by total mass 23. 20 kg plus 20 kg or 20 newtons of force. So weight equal 20 kg and 3 kg. Therefore total mass is equal to net force is 30 newtons here. That equal to total mass is equal 20 into 3, 23 meter second power minus 2. This is the acceleration. So now tension is asking to find out. So now acceleration is downwards. So on 20 kg free body diagram you take, no? You take 20 kg. So this is the tension and acceleration. So friction Fk is this direction. And it is M 20 kg. Therefore write the free body equation, that equal to Ma is equal to T minus Fk. So now is asking to find out what the tension T. T is equal to Ma plus Fk. M into A already got, that equal to 30 by 23 plus Fk equal to mu mg. Mu is equal to 0.04 into M equal to 20 into G. So this is tension. Here M equal 20. 600 by 23 plus, so here G equal to 10 if you take 2 mg. So this is 8. So this is the tension. Something will come answer. Next case. A mass of 4 kg rests on a horizontal plane. A plane is gradually inclined until theta equal to, means first of all it is, so like this, here it is resting, right? 4 kg mass. Now this inclination slowly inclined to like this 15 degrees. So here also it is in a rest only now. The mass just began to slide means the frictional force is equal to mg sin theta. So then only it is just began, will say. Just began means those two are equal. That means now mg sin theta sin 15 is equal to friction, that equal to mu into, is asking to find out the coefficient of friction, mu into mg cos theta. So this is mg will act and this is mg cos theta, cos 15. So mg cos 15. So mg get cancelled. Tan 15 is equal to mu. Mu is equal to tan 15 degrees. So that equals 0.27, I think so. Right now. A circular track. So some circular track only. Circular race track. Here is a space mission. Of radius 300 meter is banked angle 15. All 15 degrees only given. Therefore, sin 15, cos 15 and tan 15 you must remember. I think sine 15 is equal to 45 minus 15. Therefore, root 3 minus 1 by 2 root 2. Okay. Cos 15 is equal to root 3 plus 1 by 2 root 2. Okay. Sine 15 means 45 minus 30. Sine 45 1 by root 2 into cos 30 root 3 by 2. Therefore, root 3 by 2 root 2 minus. Right. Correct one. This is sine 15. So, cos 15. So, tan 15 is equal to 2 root 2, 2 root 2 get cancelled. That equal to root 3 minus 1 by root 3 plus 1. So, this is tan 15. So, that value rationalization root 3 minus 1 whole square. Okay, instead of that, substitute root 3 values. So, we will get 0.27, I think. The next problem. The circular race track of radius 300 meter is banked at an angle of 15. The coefficient of friction between the wheel of race car, the coefficient of friction between the wheels of a race car and road is 0.2. Coefficient of friction is given. And the radius is equal to 300 meter is given. And banking angle is equal to given 15 degrees. So now optimum speed of the race car to avoid wear and tear on his tire. So optimum speed of the race car between tires and road. The V is equal to Rg into tan theta root over Rg into tan theta, or tan theta is equal to mu. Therefore, V is equal to root over mu Rg. So here optimum speed means the necessary speed here. Now consider here circular track. So banking is nothing but the inner surface and outer surface. So the angle between the horizontal to the line joining the inner surface and outer surface. So this is called banking angle, and this line is called the line joining the inner and outer surface. Outer edge is somewhat raised, some height is raised, more thick than inner edge. Inner edge is thin, outer edge is thick. If you see tops sharp turns of the road, so compulsory there will be a inner side of the road. When in which direction we are taking turn, that is inner side. So inner side of the road thin and outer side is edge. Outer edge is thick. So consider. So here there is a one block of mass M. Block of mass M or car, moving car or vehicle, anything is moving. So it mg is always perpendicular to the horizontal or ground. This is the ground, horizontal road. So mg. And now this will be mg cos theta. And here there is mg sin theta. And friction is act along the friction, coefficient of friction. So the act along parallel to the surface. Friction is always parallel, either this there or this direction. The direction of the friction is outwards or inwards. That depends on the speed. Maximum speed is required or minimum speed required. That I will give the clarity. Now to the surface there will be a normal force, perpendicular normal force. So normal force is resolved into again two components. So now on this black, there is a centripetal force acting like this. Centrifugal force mv square by r. So now this mv square by r and n sin theta are equal, means banking angle d to the banking angle, the component of normal force, and centripetal force are balanced. With this velocity it can shapely it can turn. It can take shape turn here with this velocity, when this velocity gives centripetal force, means centrifugal force, which is equal to n sin theta. For example, here I want to go more speed than this. I want to maintain mv square by r will be more speed. I want to turn take the shape turn. So in that case, speed more want means to take shape turn, in the direction there is a friction component should come into the circle. Inside the circle there should be a friction component needed to be acted. That means here it is theta, means here also theta will come. The friction always act this direction. So then in the direction f cos theta. Therefore n sin theta plus f cos theta. These two are balancing the now mv square by r. So you want maximum speed, you want to take the shape turn, which is more than rg tan theta. More than rg tan theta. So the friction between the tire and rod should act inwards into the circle, into the curvature. So now mv square by r in horizontal direction. So whereas in vertical direction, so there is a friction component, mg component, and n cos theta component. Therefore n cos theta is equal to otherwise here minus f sin theta is equal to mg. So now I want v square. So here itself v square equal to, in terms of f and n I can write. So f equal to mu into n. In terms of here itself I can close it. In terms of m also. But mass I want to cancel means ratio I have to do. So we'll go with the ratio. Therefore n sin theta plus f equal to mu into n again. Mu n cos theta by n cos theta minus mu n sin theta is equal to v square by rg. Now here n get cancelled and take cos theta also common. Therefore Rg into, if you take cos theta common here, tan theta plus mu by 1 minus mu tan theta. If you take n cos theta, take common, you will get like this, v square. So therefore maximum speed, to remember while solving the problems, maximum means denominator should be less. That's why tan theta plus mu by denominator is negative. Less means mu into 1 minus tan theta. Similarly, V minima is equal to minimum speed means, for minimum speed friction should act upward direction. Friction is upward direction. The friction is outwards for minimum speed. The friction is inward to balance the mv square by r and n sin theta inwards for maximum speed. If friction is not there and you are going more than limit maximum speed, you will go out of the outside. If friction is not there, you are going minimum than required speed, then you will fall inside. That's why the component of friction is balancing. Already there is a component of normal reaction and centrifugal force are balancing at required speed. I want to move more than that speed. There is a balancing force inside the circle, component of balancing force inside the circle, that is friction. So I hope V minima is equal to, similarly it will come the root over Rg into tan theta minus mu by 1 plus mu tan theta. That means here it will come, this sin cos theta will go this side, mv square by r plus cos theta is equal to n sin theta. This will become plus, means that is here minus will come. So therefore tan theta minus mu only is correct, not mu minus tan theta. So I am verifying, right? Here n sin theta minus f cos theta equal to mv square by r. So minus mu into n. So n cos theta will take out tan theta minus mu in the numerator. So this is V maximum and V minimum formulas. So in this case, so tan theta value, tan 15 value, 40 degrees in degrees, in radius 0.27 radians. So that will be the answer. Last two questions. A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius is given without reducing the speed. Means is moving limit speed. The coefficient of static friction between the tires and road is 0.1 is given. The cyclist slip while taking the turn, yes or no, you have to check. So is how much speed is coming to near the turn? The speed is coming is equal to 18 km per hour. So now verify that is in how many meter second hours. So this will be 5 meter second hours. This is the required, it is the speed with which he is coming to the take the turn. But because of the coefficient and the radius, so the speed required to take that turn of radius 3 meters is equal to Rg, R into 3 into 10 into mu, that equal 0.1. That equal to root 3. 1.732 is needed to move. This is the limit speed at the safe turn. But he is maintaining 5 meters second. He is not reducing. He had to reduce actually, but not reducing. So he is not the student, I think so. So he'll go out of the circle. So this is means he'll slip compulsory. The slip take place at the turn. Take place at turning. So I hope you understand. Coming into this problem, a wooden block of mass is given 2 kg. Rest on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on the top of the block. So here there is a floor. There is a wooden block of mass 2 kg. Wooden block. So on this there will be 25 kg iron rod. They are like this. So 2 plus 25 is system. Therefore 27 kg is the system. So now together go down with acceleration 0. Means these two are moving downwards with acceleration 0.1 meter second power minus 2. So what is the acceleration of the block on the floor? What is the action? Action of the block on the floor before and after the floor yields. Take G equal to 10 is given. Identify the action reaction pair. So now here I'll go with first 20 kg block. 2 kg block, sorry. 2 kg block. So now this 2 kg block, the gravitational force act on 2 kg block is action. Therefore, the gravitational force act on the floor by the block. This is, so this mg is gravitational force on block. So that is action. Now here, this is the gravitational force on floor by the block, or gravitational force on the block, on the floor, not by block, on the floor is reaction. And coming into, if mg is action on floor, means gravitational force on the floor is action on floor. Gravitational force on floor is action. If you take like that, then normal force on block is reaction. On block is reaction. But mg on block, normal force is also on the block, are not action reaction pair. Are not action reaction pair. According to Newton's law, action reaction pair should act on different bodies. Action and reaction should act on different bodies. And action is the gravitational force on the block, means the same gravitational force on the floor is reaction. The action acting on the floor is gravitational force acting on the floor you have taken as action. Then the gravitational force acting on block is reaction. So the gravitational force on the block and normal force on the block is not action and reaction pair. Action reaction pair should act on different bodies and they should give zero resultant force. So right, this is concept. And here if you take system, the force is 2 and it is moving downwards. Therefore, MA is equal to 27 means M into 0.1 MA equal to 27 into 10 mg. Mg is equal to 270 newtons. So this is the gravitational force on black means system. So the force on the floor is equal to no. So that is normal force on the blacks. So that implies reaction force or normal force. So here mg net force. So the resultant pseudo acceleration on the system pseudo acceleration will take an upward direction. Okay, acceleration. The system is moving with the acceleration upward concept. This is moving downwards, but reaction force is upwards. Therefore, N is equal to mg minus ma means ma. So that equal to 27 into 9.9. So in 270, 2.7 if you remove, we will get answer. That equal to 267.3 newtons is reaction force. The action is 270 mg. The gravitational force on the blocks is action. This is action. 270 is action. And the same 270 force act on the floor. That is reaction. Action equal to minus reaction. 270 newtons by the system on the floor. 270 newton is on the blocks. Action. 270 newtons on the floor is reaction. So here reaction net force means normal force on the blocks upward direction. It is 267.3 newtons. So this multiply means you will get 267.3 newtons. So this is reaction means reaction because it is upward acting on blocks. So the same 267.3 newtons acting on the ground is reaction. So action and reaction should be in different bodies, on different bodies. So that point keep in mind. So I hope you understand. Thank you.